Now we'll be going through exercise 2.2. So the first question is, let A is equal to 1, 2, 3, 4, so on till 14. Define a relationship R from A to A given by R is equal to x comma y, where 3x minus y is equal to 0 and x and y belong to set A. Write down its domain, codomain and its range. So it is given that set A has terms 1, 2, 3, 4 till 14, and the relation R is defined as x comma y, where 3x minus y is equal to 0. X comma y belong to set A and the relation is from set A to set A. We have to find the domain, codomain and its range. We know that 3x minus y is equal to 0. So from this we can get to know that y is equal to 3x. So we'll take values of from set A. So we'll take x is equal to 1 first, then we'll take x is equal to 2, x is equal to 3, x is equal to 4 and so on. We see here that when x is equal to 1 we get y as 3. When we have x is equal to 2, we get y is equal to 6. When we get x is equal to 3, we get y is equal to 9. When x is equal to 4, we get y is equal to 12. And when we have x is equal to 5, we get y is equal to 15. So now we see that y we get as 15, but the last term in the given set is 14. So we cannot have the term y is equal to 15 because it is not a part of set A. So from this we can get to know that the ordered pair are 1, 3, 2, 6, 3, 9 and 4, 12, which we got from these four equations. So the relation is as shown here. So from these four ordered pairs you can get to know that the domain of the relation is 1, 2, 3 and 4, because these are the terms which are present in the x value. The codomain is 1, 2, 3 all the way till 14, since the second set is set A itself, and range of the relation is 3, 9, 6 and 12, because these are the terms present in the y part of the ordered pair. Coming to the second question, define a relation on the set n of natural numbers by R is equal to x comma y, where y is equal to x plus 5. X is a natural number less than 4 and x and y belong to the set n. Depict the relation using roster form. Write down the domain and the range. So it has been given that the relation R x comma y is where y is equal to x plus 5. It has been given that x is less than 4 and x comma y belong to natural numbers. So the relation is defined from natural numbers onto rational numbers. We have to find the domain and the range of the relation. So when we have x is equal to 1, we know that y is equal to x plus 5. So we get y as 6. So similarly, when x is equal to 2, we get y is equal to 7. When x is equal to 3, we get y is equal to 8. We cannot take x is equal to 4 because x should be less than 4 as defined. So x cannot be equal to 4. So from this we get to know that the three ordered pairs are 1, 6, 2, 7 and 3, 8. So from this the domain is 1, 2, 3, because 1, 2, 3 are the numbers present in the x part, and the range is 6, 7, 8 because 6, 7, 8 is present in the y part of the ordered pair. Coming to the third question, we have set A is equal to 1, 2, 3 and 5, set B is equal to 4, 6 and 9. Define a relationship R from set A to set B, where R is equal to x comma y. The difference between x and y is an odd number. X belongs to set A and y belongs to set B. Write R in roster form. So we have set A is equal to 1, 2, 3 and 5. Set B is equal to 4, 6 and 9. So the relationship is where x comma y, the difference between x and y is odd. X belongs to set A, y belongs to set B. The relation is different from set A to set B. So first we'll take the difference between all the numbers given in the two sets. So we have 4 minus 1, 4 minus 2, 4 minus 3, 4 minus 5, 5 minus 4, 6 minus 1, 6 minus 2, so on till 9 minus 5. We see that when we have 4 minus 2, the difference is even, we get 2 here. Similarly, when we have 6 minus 2, we get the difference as 4. When we have 9 minus 1, the difference is even, which is 8. When we have 9 minus 3 and 9 minus 5, we have the difference 6 and 4, which both are even. So we cannot consider these 5 terms since the difference should be an odd number. So considering these numbers, we get the relation as 1, 4, 3, 4, 5, 4, 1, 6, 3, 6, 5, 6 and 2, 6. You can see here that all the numbers in the x position are from set A and all the numbers in the second position are from set B as per the defined relation. Coming to the fourth question, we have a figure which shows the relationship between set P and set Q. we have to write the relation in set builder form and in roster form. Also we have to find the domain and the range. So we can write the given figure in a simple form. We see that 5 is linked to 3, 6 is linked to 4 and 7 is linked to 5. So 5, 6, 7 are the values of x, 3, 4, 5 are the values of y. So in this we see that the difference between both the numbers is 2. The difference between 5 and 3 is 2, 6 and 4 is 2, 7 and 5 is 2. So we can get to know that the relationship is x minus y is equal to plus 2. So if we keep y on one side, we get that y is equal to x minus 2. So the relationship in set builder form will be r is equal to x comma y, where y is equal to x minus 2, x belongs to set P and y belongs to set Q. And the same in set builder form will be 5 comma 3, 6 comma 4 and 7 comma 5 as shown in the figure here. These are the two terms paired up. So from this we can get to know that the domain is 5, 6, 7, which is nothing but the values of x, and the range is 3, 4, 5, which is nothing but the value of y. Coming to the fifth question. So let a is equal to 1, 2, 3, 4 and 6. Let R be a relation defined as a comma b, where a and b belong to set A. B is exactly divisible by a. We have to write down the relation R in roster form, find the domain and the range of the relation. So it has been given that set A consists of 1, 2, 3, 4 and 6. We have a relationship with A comma B, where B is exactly divisible by A and B belong to the set A, and the relationship is from set A to set A. So the definition says that when we have B divided by A, we get the remainder as 0. So if we apply this condition to the above set, we get these are the following ordered pairs of the relation: 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, 1 comma 6, so on till 6 comma 6. So in all these pairs we can see that the remainder will be 0 and B is exactly divisible by A by giving the remainder 0. From this we can get to know that the domain consists of 1, 2, 3, 4 and 6, which is nothing but all the x values. Range is 1, 2, 3, 4 and 6 again, which is nothing but all the y values. Coming to question number 6, determine the domain and the range of the relation defined by R is equal to x comma x plus 5, where x belongs to 0, 1, 2, 3, 4 and 5. So we have a relation here where R is equal to x comma x plus 5 and x belongs to 0, 1, 2, 3, 4 and 5. So from this we can get to know that y is equal to x plus 5 and y belongs to natural numbers or integers. So from the above relation we can see that the first order pair is 0 comma 5, because if we take x is equal to 0, then y will be 5. If we take x is equal to 1, we will get y as 6. If we get x is equal to 2, y as 7. If we get x is equal to 3, y will be equal to 8. If we get x is equal to 4, we will get y is equal to 9. And if we get x is equal to 5, y will be equal to 10. From this we can get to know that domain is 0, 1, 2, 3, 4 and 5. This is nothing but all the x values of the relation. And we get range as 5, 6, 7, 8, 9 and 10, which is nothing but all the y values from the relation. Coming to the 7th question, write a relationship where x comma x cube, where x is a prime number less than 10 in roster form. So we have the relation where x comma x cube is the ordered pair, x is a prime number less than 10. So from this we can get to know x is equal to 2, 3, 5 and 7. These are all the numbers prime numbers less than 10. So x cube will be cube of these numbers. 8 is 2 cube, 27 is 3 cube, 125 is 5 cube and 343 is 7 cube. So from this we can get to know that the ordered pairs are 2 comma 8, 3 comma 27, 5 comma 125 and 7 comma 343. This is the relation represented in roster form. Coming to the 8th question, let a is equal to x comma y comma z and b is equal to 1 comma 2. Find the number of relations from a to b. We have set a is equal to x comma y comma z and set b is equal to 1 comma 2. So we have to find the number of possible relations which can be done. So first we'll find out the number of terms in a. Number of terms in a is nothing but 3. We have 3 terms. Similarly, number of terms in b is equal to 2, since we have just 2 terms in set b. So number of terms in a into b will be 3 into 2, which is equal to 6. So now we have to find the number of possible relations. So number of possible relations is given by 2 to the power p into q. P into q is nothing but P into Q is nothing but number of terms in A into B, which we found out, which is 6. So the number of possible relations will be 2 to the power of 6, which is equal to 64. So for the two given sets, set A and set B, we can have 64 different types of relations defined for these two sets. Coming to the final question of this exercise, let relation R be on integer set defined by R is equal to A comma B, where A and B belong to integers and A minus B is an integer. We have to find the domain and range of the relation. So we have the relationship where A comma B, where A and B belong to integers and A minus B is an integer. We have to find the domain and the range of the relation. So we know that when we add or subtract any two integers, the resulting answer is also an integer. For example, if we take 1 and 2, 1 plus 2 will be equal to 3. 3 is an integer. Or we take 1 minus 2, we get minus 1, where minus 1 is an integer. This is nothing but the closure law of addition and subtraction. So from this we can see that whenever we subtract any two integers, the answer will also be an integer. So from this, domain of the relations will be integers, because the two numbers taken for subtraction is always an integer, and the range also will be an integer because the value of B will always be an integer and value of A will always be an integer. When we subtract these two numbers, we get an integer. So the domain and range of this relation will also be equal to the set of all integers.